Continuation of factoring. This is how we're going to factor the sum and difference of two cubes. But first of all, you have to realize if they are cubed. So if I look at the example of the basic models on this note paper, here I have a cubed plus b cubed. A cubed is a cube. Any power of 3 is a cube. And so when you look at your polynomials, you're looking for coefficients or constants to see if those are cubes as well. Really, it's not that difficult of a feat to factor the difference of cubes. Sometimes, though, students make minor mistakes. All right, let's look at the model. You'll be given the models on a test or a quiz. You just won't be given this part. So this part here, what I'm going to write, I would be willing to give you this model to use to jog your memory. Just like when we factored the difference of two squares, the dots, we took the square root of the first and the second term. Here we're going to take the cube root. Okay, so what's the cube root of a cubed? Well, that's a. And what's the cube root of b cubed? Well, that's b. And the sign in the middle, you keep it. Okay, if this is a cubed plus b cubed, then this is going to be a plus b times the quantity. Now here's where, if you didn't know how to use the model, or I'm going to prove to you why the model works, is to what do I multiply a with to get it to be a cubed? Well, that's a squared. And what do I multiply b with to get it to be b cubed? Well, that's b squared, okay? And it's always plus here because whether the b is positive or negative, when you square it, it's going to be positive anyway. So it's always plus on the end. So we can set up the next model, the template, if you will. This is a, this is b, the sign in the middle is minus, so that sign is minus. This is going to be a squared, this is going to be plus b squared. Now, because we don't have any middle terms, okay, we don't have, an a squared b and then an ab squared and finally to a b cubed, because we don't have those middle terms, there must have been some opposite signs occurring. And that's what happens right here. If this is plus, then this one is minus. Remember, the end always has to be plus. All right, so this is minus ab, and this one then is going to be plus ab. So if I give this part to you that I wrote in green on a test or a quiz, you should be able to know that this is how the cubes will factor, because a times a squared is a cubed. That's going to be the giveaway right there, that this is how cubes factor. Okay, again, these signs have to be opposite. I'm going to write OPP, abbreviate, opposite. And these signs have to be opposite. This will always be plus on the end. All right, so how are we going to do this? Well, we know that this is going to factor as a plus b times the quantity a squared minus ab plus b squared. I have to figure out what my a and my b are. I look at x cubed, I know that's a cube, it's a power of 3. 27 is a cube, the cube root of it is 3. So I'm going to write over here off in my workspace, what I should be thinking in my head is, what's the cube root of x cubed? Well, that's x. So this is my a value. And what's the cube root of 27? Well, that's 3. So this is my b value. So now I'm going to take my a and my b and substitute it into the model. This is going to become x plus 3. And now I'm going to take the a and square it. So my a is x. I'm going to square the x and get x squared. The sign is minus. A times b is x times 3, or 3x. Plus, and then I'm going to square the b. The b value is 3, so I get a 9. And that's how your sum of cubes in that example factors. Again, you'll get better at these if you practice them. That's the thing in math. You got to practice to get better at it. It's got to be thinking, and it's got to be your way of thinking and seeing it, okay, in order to learn it. All right, one more. You could choose to pause the video if you want to see if you could try this one. If not, then just follow along. in the video here. So again, this is going to be AB, this is A squared, this is AB, this is always plus B squared. I'm looking, my sign is minus, so that's minus and that's plus. So that's just me setting up the template. Now I have to know if 125 is a cube. I happen to know that it is. So the cube root of 125x cubed is 5x. Okay, this is my A value. 343, that's a cube. The cube root of 343 is 7. This is my B value. So now I'm going to take my A and my B and substitute it into the model. So my A is 5x, my sign is subtract, my B is 7. Now here's where sometimes students get mixed up. You know, when you take the A value, which happens to be 5x, and you square it, well, you have to square the 5 and the x. Okay? So again, if I take my A and I square it, and my A value is 5x, and I square a 5x, that's going to be 5x times 5x, or 25x squared. A lot of students always forget to square the coefficient. Remember, this is a product raised to a power, and so you have to distribute the exponent. That's the same as 5 squared times x squared. So this A squared is going to be 25x squared. Signs plus from the model. 5x times 7 is 35x. And when you square your B, you know, B squared is what squared? Well, my B is 7. 7 squared is 49. And it's always plus on the end. And so this is the answer to how that difference of cubes will factor. If you have any questions, you know what to do. Post on the homework discussion or ask in a live Google Meet. Again, I can't impress upon you enough the importance of factoring. If you have any puzzle worksheets, they need to be done on lined paper. You can choose to do the puzzle or not. The puzzle answer is not really what I'm after. It's the factoring that I want you to learn. And what else? I think that's it. If you have questions, please do what you need to do to get those questions answered. Have a great day.